Hello? Hello? So we can probably start. So if you guys can move closer, then that would be great, because we will be voting here. And so I'm Anton Keks. I come from Estonia. I'm one of the co-founders of the company called Codeborne, which is a consultancy. And we also use pair programming 100% of the time. So if you want to talk about that at the party, then you're welcome. And I will be talking about Kotlin puzzlers. So first, how can we save Java? So Java is outdated, not so cool anymore, and it has lots of volcanoes and earthquakes. It's really dangerous to be in a Java world. So why not use Kotlin? Kotlin is a small island in the Baltic Sea. Rarely no earthquakes, no thunderstorms, no hurricanes, so really safe to be. And it's a port of St. Petersburg. So it took Kotlin 6 years to get to 1.0, and now 1.5 to 1.2. They even changed the logo, so it was I really missed that teapot. But of course, making a new programming language is not rocket science. So given the amount of time, it should be perfect, but during the same time frame, actually, there's another company who managed to make some rocket stuff as well. So, but let's talk about the puzzlers. Who have been to a puzzler talk before? Okay, some of you. So basically, puzzlers are short programs with curious behavior that I will show on the screen in the IDE. I have errors and warnings turned off in my IDE, so it's a warning for you. So you don't try to get a hint from the IDE. So the question would be, what do they print? And you vote for the correct answer. And then we run the program and reveal the mystery. And then somebody from you tries to explain why the program prints what it does. And I have some flags here, sponsored by JetBrains, as a prize. So if you do that. So Kotlin puzzlers. Actually, I was inspired by the talk by Andrei Breslov and other guys from JetBrains, who actually told that Kotlin was specifically designed to avoid well-known Java puzzlers. So, of course, an ideal programming language doesn't have any puzzlers, but Kotlin is pragmatic, not ideal. So there are lots of puzzlers already known. I started collecting them maybe a year ago, and now there's quite more than 50 already in my repository on GitHub that you can check later. And all of the puzzlers that I run today, I run with the fresh Kotlin 1.2 release candidate. So this is the GitHub repo that you can check for the other puzzlers. So I'll show you a selection of those. So let's warm up with an easy one. So that's a small program. You see a variable x, which equals foo, and it's checked if it's is foo or not a foo. So who thinks that it is A, that the program will print is foo? So some of you, yeah, I would also think, because Kotlin actually calls equals here if we are Java developers. So who thinks it's not a foo? Okay, there are a couple of people. Okay, so those who have attended any puzzler talks, you know that actually you need to vote for a non-obvious answer. So who thinks it will not compile? Okay, some of you, actually half of you. And who thinks it will be typecast exception? Okay, also some of you. Okay, let's now run it. So I don't hear the drum roll. Okay. And so the program does not compile. The correct answer is C. And that was just a warm-up. And the thing is that Kotlin actually doesn't have the ternary operator. It still has the shorthand of it, the Elvis operator, but they decided to skip the full-blown stuff. So you can think that Kotlin is somewhat worse than JavaScript in this sense. But I hope they will add it at some point. So now let's go to the more crazy stuff. So we have a simple program here, like a function hello and a bunch of weird code inside of it. So what do you think this program would do. Who thinks that it will be just hello, A? Okay, some of you. Okay, who thinks it will be double hello? Okay, there's still people thinking that it can happen. Okay, who thinks that it will not compile? And I warn you, like, yeah, there are a lot of people, and I warn you, yeah, if you have an answer like that in a puzzler, then you should think very seriously about that. So, and who thinks that it will be something else? Okay, also some of you. So let's give it a try. For some reason, the drum roll doesn't work perfectly here, but it prints just hello. There were only a couple of hands, so who wants to explain? So there's a hand there. Please help with the microphone.
Can we see the code?
Yeah.
Okay, so return hello will actually compile because it's an expression, so it can be used and it could be understood as a unit, but it will be run, maybe. It will be compiled and run before the throw and before the return, etc.
Yeah, but why the hell can you write the code like this? Okay,
because expressions in Kotlin are assignable.
Yeah, very good answer. Actually, everything in Kotlin is an expression, and actually, if you already, do you know what this expression actually, what is the result type of this expression? Yeah, it's nothing. So, and nothing can be assigned to anything, so that's why you can throw it thousands of times and you can return it again, and actually this code it just will never be executed because of the first return. So you got a flag. I don't know if somebody can pass it. Whoa. Maybe maybe we should skip throwing. So let's go further. So we have a sneaky return puzzler. So that one is a classic one. So maybe you have seen it somewhere, maybe not, but let's look at it. So there is a list of 1, 2, 3, which is passed to a function, and then it's iterated, and basically numbers above, or actually below 2 are printed, and then the OK is printed. So what do you think? If for some reason doesn't work, and you will get 1, 2, 3 OK, where and A? Who thinks? Nobody? OK. Who thinks that it will be 1, 2 OK? So it's a very logical answer. I would vote for that as well. So who thinks that will be option C, 1, 2? I wonder why. OK, and who thinks that it will be the infinite loop? OK. Everyone believes in Kotlin. So let's run it. And the drum roll, and we have 1, 2. So who wants to explain? I think the first one was there.
So the for each runs each time, and it runs on the 1 and it prints it, and then it runs on the 2 and prints it, and then it gets to 3 and 3 is greater than 2, so it hits that return, and since it's not a labeled return, it returns the actual function and not just the for each, so it returns the whole function. And
yeah, so it's not Java. So if you want to emulate Java, you can do like that. So you run a flag, so you can just pick it from here later. Okay. So yeah, in Kotlin, return actually returns from the nearest function declaration. So another way of fixing that is to have like an anonymous function here. Then it will return from the function. So let's get moving. So we have a code like this. So some of the puzzlers already submitted by the spectators of my other talks. So. Like this one. So we see very easy one. We have a variable called x, which is assigned to 1, 2, 3, and then it's checked if it's string and an int at the same time. Then it's incremented, and the length of the x is added, and so we get, I guess, 1, 2, 7, right? So, and actually, maybe this can be the result of the new unknown, not so much talked about feature in Kotlin 1.2, where it can actually convert the types on the fly. So let's see. So who thinks it will be still 1, 2, 3? Okay, some of you. Who thinks that it will be 1 to 7? Yeah, we believe in new features in Kotlin. Who thinks it will be class cast exception? Yeah, maybe it should be. And who thinks that this is a nonsense code and should not compile? Of course, not so many, but I warned you about the last option. So let's run it. So we have, and it's 1, 2, 3. So who wants to explain? Yes, here.
I know the behavior changed recently, like you were saying, but normally, I'm sorry. Normally, whenever we have a variable, then it's just, and you do it in a print line, it's just going to run its toString if it's not a string. But the increment plus length is never being called because x was never possibly assigned as an int.
Yeah, that's correct. Basically, you earn a flag, but I wonder why this code compiles. Actually, I was lying about the new feature in Kotlin. There is no such features. Kotlin is a statically typed language, but I would guess that this kind of code should not compile because, yes, this is an impossible condition. But if we look at the disassembly, actually, the code for this is actually generated, but it is never executed. So that's a trick how to fool the compiler. So let's go to the next one. It's called the order. So this one also was submitted. And very easy class. We have one variable, initialization block, and a function, which is called. And we just create a new instance of this class. So what do you think? Like we're actually printing the length of the C, of the property C. So who thinks that it will be 0? Yeah, logical answer, couple of hands. Who thinks that it should be null? Okay. And who thinks that it will not compile? Yeah, nice. You really believe in guys who write the compiler. Okay. And who thinks it will be something else? Totally something else. Okay, there are some people. So let's run it. So the drum roll, that doesn't sound nice. And do you remember the guys promised that we'll never ever get null pointer in Kotlin, in pure Kotlin. There is no interrupt here. So who can explain? Yeah.
So the private val is never instantiated. So when you call it shouldn't compile because it's never instantiated anywhere. And so it's like, hey, you either have to instantiate this or make it nullable, which it's not nullable. So, right?
It's not very exactly correct, but probably you are thinking the right thing.
Okay. So it either has to be declared null or it has to be.
Yeah, actually, the code compiled. The code compiled, and it produced a null pointer exception at runtime. So maybe somebody else. I think there is a hand here. Yeah.
Yeah, so it's allowed to instantiate vals in the init function, but because you call the function first, it's not instantiated yet, and yeah. That tricks the compiler.
Yeah, and it's actually, this kind of thing should actually be caught by the compiler, but it's not. It's actually, I have another one here, you can look at it later, which also have a similar one, another way, more complex way of getting the null pointer in Kotlin. So there are probably even more ways coming. But hopefully these kind of issues can be fixed, but the guys from JetBrains already told me yesterday that it's really difficult. So let's get the next one. It's called one-child policy. So here we have like a basic, like a tree-like structure design. So we have a class called node. It's open, so we can extend it in parent, and we actually create two childs here, child 1 and child 2. And when we call the lookup method on the node, we print its name. So basically, we have a parent, child 1, child 2, and we just create the parent. So who thinks that it will print child 1 and child 2? Okay, you need some time, I see, from yours. So basically, the printing happens here when the apply function calls the lookup on both of the newly created children. So you call lookup on child 1, you call lookup on child 2. And of course, there is a trick. So who thinks it will be child 1, child 2? The easiest answer. Nobody thinks. Okay. I would think that it will be child 1, child 2. Okay, who thinks that the second child will be gone and only first will be there? Child 1, parent is one person. Okay, or maybe 2. Okay, who thinks it will be parent and child 2? Okay, there are some others. And who thinks it will be none of the above? Something else. Doesn't compile, exception, whatever. Okay, some people. So let's get it running. So it's child 1 and parent. So who can explain? Yes.
It's terrible code.
Okay, the disclaimer about the puzzlers. Don't write code like this, of course.
So the function called child returns nullable node,
Yeah.
which is essential, and the first one applies to the nullable one, so it's invoked on the node result here, and that's why we see child 1. But then the second one cannot be applied on the nullable, but it's applied on the nullable because I think you can apply it on nullable, but the method call goes to the outer class, which is a parent, and then, that's
Yeah. So I'm giving a hint here for everyone to understand. So if we enable the errors, actually you cannot call the lookup on child 2, and that's why the compiler sees that the next available lookup is on parent and calls it. So that's the trick. And so don't do like that, basically. then everything will be fine. So yeah, well-earned flag. So let's go further. We have the puzzler called 2 lambdas. So very easy one. Again, we have a type alias, L, which is lambda, taking string as a parameter, returning a unit. And we declare a function that takes 2 of these. And with the default values of empty lambdas. And actually, I will do this thing. And we call both of the provided lambdas here, 1 and 2. And we use 2 different styles of calling of the foo function. So who thinks that it will be 1, 1, 2 times 1? Okay, 2, maybe. Okay, who thinks it will be 2, 2? Nobody, okay. Who thinks it will be 1, 2? Okay, that makes sense. It should be 1, 2. It's written in that order, right? So, and who thinks it will be something else? Okay, the most of the people. So let's now run it. So, and we get 2, 1. So,
when you omit the parentheses, when a lambda is passed without parentheses, it has to be the last argument of the function. So that first call to foo, we actually pass 2 as the print. And the second one, we pass just the first argument, and then we let the default argument of 2 be
yes, that's correct.
an empty lambda.
So basically, sometimes when you omit the parentheses, it can be very dangerous. Maybe something else will happen, not the same thing. Otherwise, I would think that, yeah, it can be the same. So, correct. The last parameter is past the lambda without the parentheses, and with the parentheses is the first one. So, let's take the next one. It's called the property override. So, here we have a little bit more code. So, we have a class called named. It declares a property called name, and it overrides the getter. And if name is null, it's nullable, then we return unnamed. Then I have a class called person. It extends the named, and it actually overrides the property. And the setter will actually add Mr. to the name. So I guess this is very common in the United States, right? So, and we create a new instance of person. We assign it the name. Basically, we call this setter for our Java developers. And we then call the getter. So easy. So who thinks that I will still be Anton without the Mr.? Okay, people are hesitating, but still, some of the hands go up, so that's good. Okay, who thinks that I will become a Mr. Anton? Okay, many people. And who thinks that I will lose my name? Also some people. Okay, and who thinks that it will be null for some reason? I don't know. Okay, let's. There is no option, it will not compile, otherwise everyone else would vote. So let's go. So drum roll, and it's unnamed. So where did my name go? Or maybe somebody who haven't answered yet? Yeah, maybe here. Or
Terrible code.
okay, maybe actually you actually have answered. Maybe somebody else wants to answer. Because I know that you know. You already got the flag.
Okay, I can give my flag to one. Basically, I think Kotlin generates private field for every property. So your super field is different from the child field that you reference in the setter. So basically, when you call in the getter like super.name, it's not seeing your field that you declared in the child class.
Yeah, that's correct. I will explain a little bit more. So there is a concept of backing field for the property. And here we have a property name, which has one backing field where the name is stored. And it belongs to a class named. So when we want to override the property, it's actually a weak point in Kotlin syntax at the time, I think. So it's very easy to introduce a new backing field with the same name. So basically this class person introduces a new backing field because we assign a value to it, like this here. And really the getter, it still delegates to the backing field of named, but the setter would set the field of person. And that's why the getter still is left as null. And we get this. So yeah, how to fix that? Somebody knows? Yeah, you can also omit this, for example, or there are many options. Or you can remove this, and you can actually do this, super.name equals when you are overriding the field. Then it will, both of the getter and setter will use the backing field of the parent class. So you'll not get the flag, you already have. So let's now look at some operator overriding. So it's a fun feature, like James Gosling in 1995 decided to omit this feature from Java, but Kotlin guys told us that no, it was a mistake. We still need to override operators. So you can see we can define our own plus operator, which will actually make a mistake to this addition, and it will add an additional one to that. And we just call it 3 times in three different ways. Like Kotlin syntax allows us to do that. So who thinks that, and basically -1 plus 2 is 1, so who thinks that our operator, for some reason, will not work, and we still get 1 all 3 times? So, yeah, there is at least one brave person who thinks that. Okay, who thinks that all of the 3 will actually add an additional 1 to these operations, and we get 2, 2, 2, at least it will be consistent, yeah. So at least one person as well. That's good. So who thinks that we will get different results every time? So, oh, there are quite many people. Are you all like experienced Kotlin developers? You get these mistakes all the time. Okay, and who thinks it will be also like 2 minus 4 minus 4? Okay. Okay, some hands. So let's run it. I don't get why my prime roll is not working properly. So yeah, you get the different result every time. So who can explain why for each of the cases? Who haven't answered yet? I think the hand is here. Yes? Okay. Who wants to explain? Okay, there is a hand there.
Yeah, is the actual plus sign not being overridden or redefined there, but the second one is works correctly, and the third one actually is. I'm assuming the regular plus isn't getting redefined there.
Okay, yeah, that's correct. That the regular plus actually it already exists, and fortunately we cannot redefine that, so we can avoid all the pitfalls that we have in C++. So that one works properly. We get 1 as a result. So the second one is because the function is declared as an infix, so we can actually call it and get the result of 2, because this function adds another 1 here, so we get 2 in the second case. And the third case is the funniest one, so you probably know.
It looks like the minus sign is pointing to the expression.
Yeah, that's correct.
That's what I was going to say, that the minus operates on the 1 plus 2 using the original plus function. That's not infix.
So the thing is, yeah, if the int class, it already has the function int, so we cannot define a new extension function that will shadow the original function. So the original plus is called here, but the problem is that it's called like this. So this is a big, huge problem in my mind in Kotlin. I don't know. I really hope that they can fix it, but there will be compatibility problems. Probably somebody already relies on that. So yeah, the way to fix it, of course, is like this. So we get the expected 1 as a result. So, but it's crazy with this minus. I really have a problem with giving the flag here, but I will give the. Okay, let's give it to that guy. Okay, let's. Okay, sorry. You have another chance. Okay, now we have a really nice puzzler called Mars. So let's imagine we have a population on Earth. We have several cities like San Francisco, Tallinn, where I come from, and Kotlin is an island. And by the way, the city Kronstadt is on that island. It has a population of 43,000 people. And basically, we create an instance of population, and we delegate populations of these cities by map. So it's a very nice feature in Kotlin language. So you can delegate properties to a map. And when we provide a map with some correct values from Wikipedia, of course, and then many years have passed, and Elon Musk has sent us all to the Mars. And so we just got an empty map, and the Earth is like deserted. So, and then we print how many people is left in all of these cities. So who thinks that will be 0, 0, 0? So all the people are gone, really? So, 1, 2, couple. Okay, so yeah, where do the zeros come from? That's an interesting question. So who thinks that it's really hard, and probably Elon Musk will fail and will not send us all to Mars? So yeah, some of the people don't believe in Elon Musk. It's a pity. So let's see who thinks that will be null pointer exception that we are promised that we will never have. Okay, some other people. And who thinks that it will be no such element exception? Yeah, this one is popular. I would guess too, because like empty map, there should be no value with this key, but let's see. The drum roll. And we have, like, as we can see in the movies, it's really hard to survive on Mars. So basically, we're not going there. So who can explain? I think the first one was there.
So when you instantiate the population class, you give it the first map that is actually populated with data. And when you set up the delegates, it has a reference to that map. So when you go and you overwrite the city's property of population, the delegate is still the original map. You've only overwritten the property.
Yeah, that's correct. Actually, even though the cities here is a var, so you can change, it's a property by itself, but the delegates, they actually store their own instances to the original map. And that's why they actually still work with it. So if we would clear this map, then no such element exception would be thrown, but otherwise it has no effect. So let's get moving. So we have another crazy one. So the love for exclamation marks in Kotlin. You know, this one is called antimatter because in Kotlin you can create matter from a null. So basically you can convert null to a unit. And so two operators overridden on nothing. And you guys really know that the type of the inferred type of foo is what? That's a bonus question. Yeah, the inferred type of foo is, of course, nothing, nullable nothing. So if there is no other type provided, then it's nullable nothing, the type of just null, but inferred by the compiler. We can even verify that. It's too small for you to see, but it is. So basically, we can do this kind of stuff with the foo. And so the matter is, you need to count the exclamation marks, and you need to decide what will happen. So who thinks that in the end we will apply everything, and we will, from a null, we still get null. So no antimatter effects. So nobody, yeah. It's probably impossible. We need to get something from a null. So who thinks it will be units? No, it's quite logical. So you probably counted that there are odd number of exclamation marks here, where they are like the not operators. So we will be left with the unit in the end, and we do something with that here. We basically assert that it's a not null 2 times. We can also add a couple of times more for clarity. And so if you're really sure that it's a not null, then in your code you can write like that all the time. And who thinks it will be Kotlin null pointer exception? Yeah, and this is the exception that is thrown when the null assertion doesn't work. And who thinks that it will not compile, because this is some crazy code? Yeah, some people, of course. This is a good option always to vote for. So let's see what happens, and the code does not compile. So who voted for not compiling? Yeah.
That's terrible code. By the way.
I really appreciate.
I think that you cannot manipulate a nothing at all. So you cannot extend it. It does not exist. So you cannot create a function that extends it or takes it as a parameter.
That's incorrect, unfortunately. Who else? Actually, you can read the reason why it's not compiling. Kotlin is supposed to be giving very good error messages sometimes. So, anybody else? Yep, here.
The compiler doesn't know which method to invoke. You have the same method signature twice.
Yeah, that's what it says, but why?
Because they have the same method signature. I guess I don't know the technical details behind it, but you can't have 2 methods with the same method signature. Like, that's not a thing.
That's not exactly correct. Maybe you will try?
Unit inherit, sorry. Does unit inherit from nothing, or the other way around?
Unit, no. Units inherits from any, and nothing is actually assignable to any type. So,
could it be that it is because nothing is nullable? Well, your overload is on the nullable nothing, which in turn is a unit because of the nullability.
Not quite. Okay, I'll answer that myself. I actually already answered that. So the problem here is that there is ambiguity here. So when you're calling this not operator and you're calling it on nothing, the type of foo is nothing. And I already told you that nothing is assignable to any type in Kotlin. So basically, it means that for this exclamation mark, both of the not functions actually match. So because you can call it on a nothing and you call it on a unit because nothing is assignable to unit. Nothing is assignable to anything. And this the same stuff when we had multiple return statements, the same reason actually. And that's why it doesn't compile. But otherwise, the most logical answer would be Kotlin unit, of course, because you just convert it several times to unit and then you just assert it several times. So I will leave one of the flags to myself. So let's look at this one. It's called weird chaining. So this one is actually submitted by one of the other speakers at this conference. Ah, you are here. Very nice. We have a really simple one, if-else stuff like we use in Java all the time. And we print number sign, like we have numbers, negative, 0, and positive, and we print these signs for all of this, like pretty easy. So who thinks that this code just works? So we get negative, 0, and positive, option A. So nobody believes in Kotlin anymore. Okay, one hand, nice. Okay, who thinks that negative and 0 and for some reason positive will be gone? So there's one hand, maybe 2, 3, okay. Who thinks that it will be just negative and positive and the 0 will be omitted? Okay, there are also some hesitating hands. And who thinks that it will be 0 positive? 1, 2, like 3 maybe, okay. And the rest, none of the above? There is no such options here. Okay, let's run it. And we here have 0 positive. So I think there is a hand.
Just a guess that the let is binding to the, not the complete if else, but rather just the latter part, if and else. Or not? Yeah.
Can you repeat that? So,
that let doesn't apply to all the cases, only applies to the second half, like if else.
Yeah, that's correct. The flag is yours, so basically the code works like this. So the if-else is a single expression, and let is called on the last expression, and the first if is like part of another expression. So, of course, if you want to fix that, you would write a very nice code, and it will look like this. But as I heard it several times already, it's a terrible code. Don't write code like this. Of course, don't use let on if-else directly. Add parentheses at least. So let's have a next one. So we have a really nice puzzler. So we have a variable called I. It's 10.5. What is the type of I? Probably you know. It's double. Yeah, it's double by default. So, and we use the very nice when syntax. When we check if it's in the range of 1 to 10, then we print in. If it's not in the range, we print not in. Or if it's something else, we print else. So what would that be? So who thinks it's in the range? Yeah, some of the people. Okay, what are you thinking? I don't know. Really weird. I think I would vote for B. It's not in the range. Come on. Who thinks not in the range? Yeah, very few people. Okay. Who thinks it will be else? Yeah. Okay. that's the winner probably. Or with not compile. Yeah, probably checking that double is in a range of ints. It doesn't make really sense. Kotlin is a type-safe language, right? So let's run it. And the correct answer is it's in range. Who can explain? There were many hands. Yes, please.
I'm guessing it converts the double to int and then does the comparison. Is it in the range?
Yeah, it's the correct answer. You got the flag. But the thing is, if you would run this code with Kotlin 1.0, that would work correctly. The answer would be not in. For some reason, at one point in 1.1, they actually fixed or improved the code here. Actually, I don't see the source, unfortunately, but actually, yes, they do truncate the double to int, and then they check, and it's really wrong. I hope they will fix it again back like it was in 1.0. And the next puzzle is called overextension. So you can extend many things in Kotlin. So how about that? We have an operator function called invoke, which actually takes the receiver and adds the lambda that is provided to it. So we have the extension function called Z, or you say Z in the United States. And it adds an exclamation mark here. And we also override the toString, and we add another exclamation mark at the end. So, and we have this funny thing here. So, will it compile? I don't know. So, who thinks it will be A? Exclamation mark X. You need some time? No? Okay, there's one hand. Anybody else? Okay. Who thinks it will be XY? Okay. More people. Who thinks there will be XY with an exclamation mark at the end? Yeah, nice. But I told you that you cannot add an extension function with the name of already existing function. But who thinks it will not compile? Yeah, it's nonsense code. Why should it compile? Okay, drum roll. And yeah, the correct answer is XY. So who knows the reason? There?
Okay, so it actually runs as if you didn't define the toString extension method, and the reason is that if a method exists and an extension method also exists, Kotlin will always call the real method, and the string.toString exists in the string class.
Yeah, so this one is not called, but this invoke is actually, it is called. So basically you can write things like that. It's useful for DSLs. You can invoke a string, basically, with a lambda, which is provided here and is added to X. That's why it's X, Y, and the Z at the end actually adds another exclamation mark here. So that's a little bit puzzly. So I don't have any flags, but I have a different thing. And okay. And yeah, you can still have the. Okay, and the last one is there is a proverb in Estonian language. It's called "Good child has many names." You already want to answer?
No, I want to ask a question about the previous.
Yeah. Okay.
Is there any way to call that toString method? Is it?
No. There is no way to call this thing.
It lets you define something
Yeah.
you can't use.
Yeah. That's unfortunately true. Yeah, I would also think that it should be a warning, but there is no warning at this time.
So
yeah.
Why would
You can call it from Java, by the way, because it will generate a static toString method with a parameters.
why would dot to string on a string even exist? Because println, it's like, why would it call dot to string on a string? It's already a string. It doesn't need to typecast anywhere, right?
Yeah, here it would, but println actually, I think it calls toString on other objects that it doesn't know about. But for a string, I think there's an overloaded version which just prints the string. Actually, there is not. There is only the any version which calls to string in any case on a string. So, and the last one, so the proverb, this good child has many names. So we have a class C with a function called sum. It has two named parameters with default values and just returns the sum of them. And there is a class D which extends C and overrides the function sum and calls the super function. And we basically have two instances of it. Both of them, actually we have one instance and two references to the D. And we just call this function 2 times, and we pass the x as 0. So you can see the default values are 1 and 2. So who thinks that it will be 2, 2? Where are they? Okay, there's one brave guy here. Who thinks it will be 1, 1? Nobody. Okay. Who thinks it will be 2, 1? Okay, more people. That's good. And who thinks that it should not compile? Yeah, I would also think that probably it should not compile. Because if you have noticed, their x and and y here are actually mixed up. So let's run it. And what we have, the correct answer is 2, 1. So who can answer? Somebody who haven't answered yet, please. Okay, the rest. Okay, there's behind, yeah.
I'm not really sure, but the second, when it does C, is C equals to D, does that make it not a D, like a D class, but a C class? So it'll call the regular supersum. Oh, sort of confused myself.
Anyone else?
So on the first call, it uses the definition in sum, or in C. So x equals. In the first call, it uses a definition in C. So x equals 0, y equals 2. It prints 2. In the second definition, it uses. At the second call, it uses a definition in D, and you're using. So x equals 0. The second parameter is 0, the first parameter is default. It switches them, so you're setting x is using the default value for x because you didn't specify y, and then the second value, y, you set to 0.
Yeah, that's correct. So the reason here is that JVM provides the polymorphism. So basically, the correct sum is called. In both cases, actually, this method is called because we have an instance of D. But Java doesn't have the notion of resolving the named parameters dynamically, so it is resolved statically by the compiler, and it actually looks at the type of the reference, not at the actual instance. So that's why it's 2, 1. So, and that's it. Thank you very much. By the way, you have the small souvenir. So. When I gave another Puzzler talk in Kiev this year, there was this guy sitting. It was a Java conference. There was this guy sitting, and he says that I'm waiting until somebody starts writing in Kotlin. Now we have KotlinConf, and we have lots of people already writing in Kotlin. I'm pretty happy about that. Don't look at the Puzzlers. Puzzlers are really terrible code, and you need to write the good code. So thanks again.